Hi, my name is Shelley Appleton and welcome to my round yard. This is my lovely horse Sax, and today what I want to talk about is neuroscience. So what is neuroscience? So neuroscience studies provide us information about the nervous system, how it's structured, how it functions, how it develops, how it goes wrong, plus also how it can be changed. So whilst in the past when it came to behaviour, all we could do was observe it and make some assumptions about that. But today with technological advances, we've been able to look deeper into behaviour as well as the learning process. So how does it help? So neuroscience helps us understand how horses process information, and it helps us understand the link between horses' thoughts, horses' emotions or feelings and their behaviour. So what you've got to understand first of all is just basically that we actually have two selves inside us, and so do horses. We've got a conscious and an unconscious part of ourselves. We've got a conscious part that can think and make decisions and act on things in a voluntary way, but we've also got this involuntary unconscious system that's looking after us. You know, it's looking after our cardiovascular system, our digestive system, our respiratory system, etc. And all that's controlled by the nervous system. So understanding these two selves is really important. So what I want to focus on today is the stress response, because I get to talk to a lot of horses, to a lot of people that are quite stressed, and a lot of horses that are in a bit of a bad way with stress. Okay, and understanding stress is really important because we actually do tap into stress when it comes to learning. However, too much stress is completely and absolutely detrimental to learning or performance. Okay, we need little bits of stress, a certain level of stress to be able to trigger learning and continued performance. However, and also to actually help horses learn to cope with stress as well. However, when it's too much, it all goes down the tube. So it's not good. So there's three structures within the brain that I'd like you to understand. The first structure is the prefrontal cortex. Now, Saxon and I both have a prefrontal cortex. Mine's a little bit much more developed than his, because our superpower of humans is being able to think and analyse things. Okay, so our brain's quite developed in that department. Saxon's superpower is in movement. Okay, so he has quite a complex motor control system within his particular brain structure. But we both have a prefrontal cortex. Now what the prefrontal cortex does is it takes in all information from the senses, so from your eyes, from your ears, taste, smell, touch, etc. And it helps orchestrate your thoughts and actions to achieve the goals. So it's the thinking part of your brain. Okay, so when you're functioning out of your prefrontal cortex, you're in a thinking state. You're in a thinking state that's able to learn and to do things under conscious control. The next structure is known as the amygdala. Now, the amygdala sits in the center of the brain. It's part of the limbic system. And what the amygdala is, its role is identifying threats. So it as well scans all the information coming in from those senses, but it also scans the thoughts. So if the thoughts are becoming worried and desperate and concerned, the amygdala will also switch on. When the amygdala perceives a threat, it triggers another structure within the brain called the hypothalamus to trigger part of what's known as the autonomic nervous system. So the autonomic nervous system is a division of the nervous system, and it's made up of two components. The first part of the autonomic nervous system is known as the parasympathetic nervous system. So the parasympathetic nervous system is involved, it switches on when the animal is in a more relaxed state, and so it's involved in digestion and rest, etc. like that. However, if the amygdala perceives a threat, it triggers the hypothalamus to switch on the other component of the autonomic nervous system called the sympathetic nervous system. So the sympathetic nervous system, when it gets triggered in full, will flick off the flight or fight reflex, okay, which is an involuntary reflex. So what happens when the amygdala switches on and it activates the hypothalamus to switch on the sympathetic nervous system, it causes this all these actions to take place. So it sets off adrenaline being released in the system, cortisol in the system, and this creates this physiological cascade of responses that increase heart rate, blood pressure, respiratory rate, etc. It gets a big boost of energy goes into the system, and it really sharpens the senses. So it puts the horse, or the animal, whatever, on alert, okay, to be able to deal with any threat. So how is this important? Well, it's important to understand that stress sits on an escalating scale. Okay, so whilst low levels of stress can be important to inspire a horse to learn in a learning scenario, or to, inspire it to search for answers, or to keep them focused and engaged on the handler and to actually perform, if that stress escalates to a point where the horse feels uncomfortable or threatened, you will switch on that amygdala. So they'll go from prefrontal cortex control into the thinking state into a reactive state. And that's very detrimental, because when a horse gets in a reactive state, when that amygdala turns on, your learning and performance goes down the tubes. Okay, and so that's quite a dangerous place to be. Okay, when you've got a horse that's reacting and no longer thinking. Okay, so therefore it's important to observe the horse, and to observe the horse in what kind of state it's in. Okay, and to take great notice of that. Because if the horse is feeling overwhelmed by what you're asking it to do, it's feeling uncomfortable in its environment, that's not conducive to learning and performance. So therefore it's important you observe the horse, and when the horse, if it's getting close to that state or it's flicked over, you've got to do something about it, for the sake of that horse. Now that might be something as simple as identifying that you're asking it too much and beyond what it understands or what it's physically capable of, and therefore maybe you should switch down to asking it something more simple. Or something I really want to really push home is that it might be a sign that you're not doing a good communication job, okay, that your timing and feel is out, okay, and and therefore you need some help with that, okay, because you're actually making the horse feel threatened. You're not actually inspiring the horse to learn or motivating it to perform. You're actually making it feel uncomfortable, okay? So neuroscience is important because it helps us really understand the details of, that a horse just responds how it feels, and their behaviour gives you insights into their thoughts and feelings and their emotions, and how you can use this information as feedback to make decisions when you're interacting with it. So the bottom line is, when you work with horses, you've got to keep them in this thinking state, okay? In this prefrontal cortex state, okay? Not in the reactive state thanks to the amygdala, okay? You've got to keep them, yes, you need a amount of stress that is now, but to keep them engaged and to keep them, keep them with you and focused and on the job. However, they've got to be comfortable, okay? They've got to be comfortable, and they've got to feel successful in navigating you, okay, to be able to work with us successfully. So I hope that helps.